Okay, we're going to look at another sequence and series kind of question, but this isn't a series. This looks like it might be, well, it's not arithmetic because it's not going up by the same amount. If I go this divided by this and this divided by this, T2 divided, I don't get a common ratio. There isn't a common difference. Well, what you need to do is the other type of sequence they give you all the time is called a quadratic one. So this is how you do it. This is what you do. You write down 8, 18, 30, and 44. And then you start subtracting. You go 18 minus 8, and your first difference is 10. Then you subtract the next two. You're uh, 30 minus 18, that's 12. Well, that's the second term of your first differences. And then 44 minus 30 is 14. That's the third term of your first differences. And if you kept on going, you could see if this is 14, the next number would be 16. And then you would go 44 plus 16, that would make this 60. So that's the next term, 60. And then if instead of going up by 16, we should go up by two more, we should add 18 to it. So there's the next term, 78. So the next two terms are 60 and 78. That answers the first question. Now there's a technique for calculating the nth term. And this is what we do. All we do is we subtract these first differences. We go 10 minus 12, we get 2. We don't go 10 minus 12. We always go T2 minus T1. We subtract right minus left and we get 2. 12 minus 10 is 2. 14 minus 12 is 2. When these are called second differences. And when they go constant, it's called a quadratic sequence. That's when we know it's a quadratic sequence. Now you've got to memorize this trick here for figuring out the nth term of a sequence. It's really fast. You just write 2a equals the first second difference. It's always the same number. You always write 3a plus b in front of the first difference, the 10. And then in front of the first term, you write a plus b plus c. And here's what you do. You go 2a equals 2 and you solve the equation. Oh, a must be 1. And then you take that 1 and you put it back in here. 3 times 1 plus b, and you let it equal 10. Well, that's 3. You subtract 3 from both sides and you get b is 7. And then you go, okay, b is 7. Then you take a is 1 and b is 7, and you put it back in for a and b. 1 there, 7 there, but it's supposed to equal 8. Well, 1 plus 7 is 8. We take it away from both sides, c equals 0. So into the general formula, an squared plus bn plus c. A is 1, so it's 1n squared. B is 7, so it's 7n. And there's nothing added on. Well, there's your formula. Now, the last thing, I think we'll do this all in one video. Which term of the sequence is 330? Well, now you've got your formula. You've got your formula of n squared plus 7n minus n squared plus 7n. It equals 330. So you just write n squared plus 7n. You make it equal 330. But we want to solve this quadratic equation. So we subtract 330. Now you can, if you want to, at this stage, put a as 1, b as 7, and c as minus 330. Put it into the quadratic formula, and you'll have two different answers. One will be minus 22. The other will be 15. And your answer is the positive one, n is 15. So the 15th term, 330, is the 15th term. Now, you might be good at doing this kind of factoring thing. You might go, okay, it's 33 times 10, and play with the 33 and the 11 and find the factors of 22 and 15 that'll be 7 apart. Maybe you're good at that by looking at all the factors, but you don't have to factor these big numbers. Sometimes it's faster to just use the quadratic formula and get your two answers from that. Well, that's it. I hope that I hope that helps. I hope it helps.